And welcome back for our next section. This is going to be part 5 on LlamaIndex. So we saw LangChain, we saw open source, closed source, we saw gradient, we saw LlamaIndex wrapper to do some fine tuning, but now we're going to see LlamaIndex proper to build a kind of complicated RAG system using both qualitative and quantitative data. Aligning our aim a little bit for the sesh, you're going to understand the LlamaIndex framework, and you're going to be able to leverage natural language for built-in NL to SQL tools that LlamaIndex has that are pretty dope, So what we're going to do is we're going to overview LlamaIndex. We're going to show you how to build a complex index now. And then we're going to show you how to sort of use what's called a data agent in LlamaIndex to tell you which one to pick depending on the user query. So, LlamaIndex, what is it? What do we need to know about it? Well, it was formerly known as GPT Index, and it was originally built on top of LangChain, actually. And since its inception, and obviously over the past 6 months, over the past year, LlamaIndex has really grown into kind of an amazing company that ships and shares like absolute legends. So the early dependencies don't appear to be any longer part of LlamaIndex. And so it's kind of standing alone, very much on its own, doing its own thing. But you can do a lot of similar things with LlamaIndex that you can with LangChain, that you can with many of these infrastructure tools. What their differentiation is, according to their documentation, is they are a data framework, okay? The data-centric world does not change just because of LLMs, and LlamaIndex is sort of maybe the tool you think of if you're really, really looking at complex data, although this obviously is a rapidly emerging space and is surely to not remain too clear for long because everybody's moving towards the same goals of building more awesome LLM applications. So, this is from their website, which I think is amazing, right? This actual meme. And so this is kind of very much their brand. It's all about people building stuff with their own private data, with their own domain specific data, finding that data in the places it exists, whether it's SQL databases or random folders or trapped behind APIs. LlamaIndex is sort of purpose built with this in mind. One piece of terminology here for you classic NLP nerds is that when we say documents in LlamaIndex, we're not talking about classic NLP documents. A lot of times this is very confusing because you're talking about documents like PDFs, and then you have NLP documents that make up all of the documents. Here we're saying LlamaIndex uses the term documents to refer to source documents, and they use the term nodes to refer to more classic NLP documents. So what is a node? Well, according to LlamaIndex, a node is a first-class citizen. Nodes are just chunk of source document. That's it. They inherit the metadata from the source document, and when you do a query into a vector store made of nodes, you're going to return the top K most similar nodes, and then there's sort of this nice response synthesis module built into LlamaIndex that helps you sort of figure out what is retrieved exactly. So it feels like there's a bit of an enhancement here. To create the nodes, we're going to use a node parser. We're going to take an input, which is a list of documents, files, let's say, and we're going to chunk them into node objects. There's some defaults here: chunk size, chunk overlap, etc. And you can change these. Obviously, chunk overlap of 0 is the simplest possible thing. But we're kind of using these node parsers to build out our vector store index. We're going to load documents. We're going to chunk the nodes in the node parser. We're going to then create the embeddings. And we're going to store the nodes in a vector store. All right, so same old same, right? Same. The magic in LlamaIndex, just like sort of the chain in LangChain, what we want to think about is we want to think about the query engine in LlamaIndex. That's that generic interface that allows you to ask questions over your data. Of course, a retriever is simply a wrapper around an index. In this case, we're going to be returning the most relevant context via nodes and node format when we're using LlamaIndex. But the query engine is the key abstraction, and this is where the magic happens in LlamaIndex. So we're going to build a little example here where we're going to prepare some Wikipedia data on both Barbie and Oppenheimer, aka Barbenheimer. And we're going to create an index. We're going to build a retrieval chain. We're also going to leverage the reviews done on Barbie and Oppenheimer. So this is the sort of natural language and quantitative piece. But for context, our contextual data is going to leverage the Wikipedia entries for Barbie and Oppenheimer. What we're going to do is we're going to sort of build out this decision-making reasoning engine called a data agent. And a data agent is sort of this LLM-powered knowledge worker. It's able to call different tools and get a response, store that response, and use that to sort of continue to think through that reasoning of what should be done next. Whether it's a Google search versus a retrieval in a database, or it's two different retrievals into two different databases. It's the same idea. How can we call an external tool or something that we're doing while we're doing it? From the docs, I like this line. In that sense, agents are a step beyond query engines. So they're not only reading, but they can dynamically ingest and modify. And so to do this reasoning loop, we're actually going to leverage the OpenAI function agent, which has, it turned into now this sort of JSON mode within OpenAI. So what we're doing is this agent is actually leveraging OpenAI to help make the decision and to help get the appropriate input and output format. So this sort of OpenAI's functional endpoint is helping us select the correct metadata filter and query the filtered index. Looks something like this. So it's helping us sort of make the decision as to which vector database we should be looking at. The way that you might think about this is it's sort of an agent-like action where we're looking at the query, we're looking at the metadata, and then we're deciding which metadata to filter by. We're doing a classification, and one of the things that that's so interesting here is, in the end, when we're connected to a bunch of tools, these are classification problems that LLMs are being used to solve now. It's a best practice to use them, but one could imagine a future where these problems at scale are solved with slightly simpler models that are very, very good at this classification task. So we also want to prepare the quantitative data where we're going to download movie reviews like this one, beautiful film, but so preachy, or this one, Murphy is exceptional. And these were the top, these were at the top of IMDb when this slide was made. We're going to load the CSV. We're going to create data frames. And then we're going to, from those data frames, we're going to leverage query engines that help us work with them. So for the tabular data, we're going to create a SQL database from these data frames. And then we're going to query it with the natural language to SQL table query engine, which is pretty dope to be able to call in one line. And it works surprisingly, remarkably well. And for the contextual data, we'll build the vector store index, and then we'll create the vector index retriever, and retriever query engine is going to be what we will use. You got all that? Well, if you didn't, we're going to go through it step by step now. Barbenheimer agent with the whiz.
What's up? So let me share my screen. Here we go. And hopefully you can see my screen. If you can, we're going to go through and talk about, exactly what we're seeing. So the first thing is this terminology difference. You have the notebook. I'll link it again in the Zoom chat, but in case you missed it the first time. But the idea here is that we have some terminology differences. I'll just leave you to read that. But the basic thing we're going to focus on is this idea of nodes versus documents versus source documents. Everyone's got different terminology. If you're coming from an NLP background, a lot of this will be familiar. If not, we're just going to talk about nodes as if they're little units of information. So first thing we have to do is allow us to run async in the Colab notebook. Colab is running in an async loop, and so we need to add the ability to nest async loops inside of it in order for us to take advantage of asynchronous features. We're going to install our dependencies with OpenAI, LlamaIndex, and NLTK, which is if you remember, an absolute legend of a library from classic NLP. We'll pass in our OpenAI key. We can also pass in our weights and biases key. So this is going to be our first kind of introduction to weights and biases. You don't have to do this if you don't want to. You can skip these cells and avoid weights and biases for now, but it's also going to be tucked in there for you if you wanted to see it. So the next thing we're going to do is talk about contexts. Context in LlamaIndex is very specific. The idea behind context is straightforward. It's just like a config, right? So it's a way for us to have repeatable configurations across different systems. We're going to go ahead and set up some service contexts. Service contexts are contexts we're going to pass into each service as we're using it, versus a global context, which is going to be something that applies to the whole application. We're going to use service contexts today just to avoid the situation of wondering where things are coming from. And so we'll always be passing it through to our services in each step. You'll see here that we have our text splitter and our node parser. Text splitter should be hopefully very familiar to you. It's basically exactly the same as in LangChains. And then node parser is going to be how we actually parse those chunks into nodes. Nodes are going to build up our index. So let's first create our Barbenheimer Wikipedia retrieval tool. We're going to be using GPT vector store index. This is going to let us semantically search our index for related documents. You'll notice that we initialize it with no documents, and we pass in our service context. Now we're going to grab, with the Wikipedia reader from LlamaIndex, our two film Wikipedia pages. So we're going to submit a list. The list is going to be Barbie film and Oppenheimer film. And we're going to turn off auto-suggest because it's absolutely ludicrous what this thing will suggest. So turn it off every time if you can. We just want the Barbie film page and the Oppenheimer film page. Now that we have these docs in our Wikipedia reader, we can go ahead and we can work with them to initialize some nodes. Now, what we're going to do is for each movie and for each document, we're going to get nodes from that document, and then we're going to add some metadata to each of those nodes, indicating which movie it's from. So the idea is first we'll do the Barbie film, then the Oppenheimer film. We'll get the Wikipedia page, we'll split and chunk that into nodes, and then for every node, we're going to add the fact that it's from the Barbie movie. Then we're going to insert those nodes into our index or our vector store. Now at this point, we could persist our index in weights and biases. Something that weights and biases and LlamaIndex have is an integration where we can actually version control our indices through weights and biases, which is a very handy feature to be able to have. It lets you know what your indices are built of and what data they have and how they progress through time. So it's definitely worth doing. But again, if you haven't done the weights and biases
Can you please let me
information,
share?
Sure.
we're going to go ahead and, just, skip this cell. Same for this. If you're not using weights and biases, you can feel free to skip this cell. Okay, so now we have our index set up with Barbie movies, Oppenheimer movie, sorry, not movies, but the Barbenheimer Wikipedia page set. We are good to move on to the next step. The next step is going to be fairly straightforward, which is turning this into a RAG system, right? So we have an index. All we need to be able to do now is turn it into a RAG. And the way we're going to do that is by using the retriever query engine. And we're also going to use this vector index retriever, which lets us add some additional information about what our vector store is. So in this case, it's semantic information about movies. And then we have some titles of our movies in our metadata info. You can see that we have title of the movie, one of Barbie film, Oppenheimer film. Now, the reason we want to do this is because we're actually going to leverage some metadata filtering for our retrieval process. So when the LLM determines that the movie or the query is likely to be about Oppenheimer, we're only going to look at Oppenheimer documents. When the movie is pretty sure that it's, or the LLM, sorry, is pretty sure the movie in question is Barbie, then we're going to only include documents that are from the Barbie Wikipedia page. This is going to reduce the potential noisy document retrieval. We might find something from Oppenheimer that very much relates to our Barbie query, but of course we don't care because we're talking about Barbie. In the case that both are a match, it will actually use both. Or if it's unsure, it will use both. In order to do this, we have to do some setup. This is all boilerplate, so don't get too scared. But the idea is that we have to create this model, which is an extension of the Pydantic base model. Once you start working in this space, you're going to become very familiar with Pydantic. It's one of the only ways in Python to get something similar to typing that you might be used to in other languages. Sorry, it's not one of the only ways, but it's the most prolific way to do so. You'll notice that we have these natural language descriptions. These natural language descriptions are actually important because this information is going to help the LLM populate these various filter sections. So this is absolutely a very powerful tool, and we want to be very sure that our descriptions make sense here. This is the idea that we've talked about before, and I'm sure we'll talk about again, which is that as you're working with these tools, you're not just writing code, you're also prompting, right? Our job is to always be communicating with the LLM, even when we're doing something that feels very much just like writing some code. These are actually prompts, and the way we write them matters. Exactly the same thing here, but this time we need some way to actually filter the metadata. Obviously, OpenAI doesn't have access to our environment. It can't execute code in our environment, and certainly we shouldn't allow it to. What we can do is have it return an object that can be used to call this function. And what OpenAI is going to do is ensure that it passes us something that can basically call this function. So it's going to pass us an object, which we'll use to fill the parameters in our function based on what we want it to do. So the idea here is that OpenAI is going to return to us something that can call this function, and it's going to either call it using Barbie or Oppenheimer or both. And it's going to do this through the exact match filter in LlamaIndex. So the idea here is that the LLM makes the decision of which tool to use, but we execute the code, which is a pattern that we'll want to continue to maintain as we build more complex applications with LLMs, just so we can always be sure what code we're running before we run it. In this case, it's not doing anything too crazy. We're just going to retrieve our query engine response, which is our RAG system, and we're going to base it only on the metadata that the LLM has suggested we use. So Barbie, Oppenheimer, or both. And then we'll return the response from the LLM as a string. Now we have a few more steps in order to set this up. This is using OpenAI's function endpoint. So if you're used to that endpoint, this is hopefully familiar. If not, the idea is, again, it's just going to return an object we can use to call a function. We just have to tell OpenAI how that looks. So we're going to have this use this tool to look up semantic information about films. The vector database schema is given below. We're going to have the vector database schema fed in from LlamaIndex. We don't have to fill it out manually. And then we're going to, again, provide the auto retrieve function, which is this function here. This is the one we want to be able to call. We're going to name it semantic film info. Again, these names matter. We're going to pass it a description. The description very much matters. And then we're going to pass it the schema. And the schema is going to tell OpenAI what it needs to provide. For instance, our query should be a string, and it should be a natural language query string. Our filter key list should be a list of metadata filter field names, and it should be in the form of a list of strings. And the same thing for our filter value list. After we've done that, we're good to create the OpenAI agent from tools, and the auto retrieve tool, which is what we just set up above, is going to be our only tool. What we're going to do now is we're going to query our agent, tell me what happens briefly in the Barbie movie. And basically, it goes on to talk about a response, looking for specific information about the Barbie movie. The actual retrieval process, in this case, was insufficient to answer the question, as the Wikipedia article at time that I ran the cells didn't contain a synopsis of the movie. But the idea is this is going to extract information from only our Barbie retriever, and that's it. And we can see that happening when we look in the 1B dashboard, which, again, you don't have to include this step. And if you don't, don't worry too much about it. That's the idea for the OpenAI agent using the function agent. And I think at that point, we'll kick it back to Greg to talk about the SQL half.
Yep, thanks, Chris. And so just in case you wanted to triple down on your understanding of this SQL piece that we're doing, what we're doing is we're preparing the Barbie and Oppenheimer reviews. We're making sure that we pull those things down, we load them into CSV file format, classic. We just turn them into data frames in Python. And from there, we're going to go ahead and create SQL databases that we can engage with from these user reviews. Those SQL databases will be created using the SQL database index in LlamaIndex. And then we're going to leverage this again by using this natural language to SQL table query engine. By virtue of the reasoning engine, the data agent, in other words, this automatic retriever that looks at what was asked, it looks at what we told it, each tool, each database was very good at, and it sort of makes a decision. Okay, well, based on what I'm looking for to answer this question, I'm going to go either to the quantitative or to the qualitative index as appropriate. Then I'm going to retrieve the information. I'm going to take a look at it. I'm going to consider, okay, based on anything I got before, based on what I just got now, where should I go next? Do I have the answer? Can I not answer? And all of these sort of reasoning steps along the way is going to be representative of that sort of agentic behavior that we get with these data agents, these LLM powered knowledge workers. So to show you exactly how this looks in code, spoiler alert, it looks like this. But to see exactly how we can get to such a beautiful Barbenheimer agent equals OpenAI agent dot from tools with just 2 tools, Chris is going to show us the rest of the way from here. Chris, back to you.
Thanks, Greg. And yes, we are going to do the cool thing. So, okay, RAG, we got RAG, right? I mean, you get text, you put text in the prompt, there we go. Bob's your uncle, we're having a good day. But SQL, now that's pretty neato, right? So what we're going to do is we're going to first set up SQL Alchemy and Pandas. We're going to get some data. We're going to, and this data can be found on our GitHub organization if you need it in the data folder or repo, which I will share as soon as I'm done right here. But the idea is we read these CSVs as pandas data frames, and then we set up an in-memory SQL Alchemy engine. Then we put the data frame into SQL table format using that in-memory database, giving it a name. Same thing for Oppenheimer. And then we set up a database with these tables. Now you'll notice that this is a LlamaIndex SQL database. Now what this is going to do is it's going to let Llama understand the schema of those respective tables. That's going to be very important, right? If you've worked with SQL before, you know that in order to do really anything with those tables, in order to query any information, you have to know something about the schema, right? What are the columns? What kinds of information are in the columns? Everything like this. So we're going to create that LlamaIndex SQL database. We're going to include the tables Barbie and Oppenheimer. You'll notice these are exactly just Oppenheimer and Barbie up above. And then we're going to create an NL SQL table query engine. We're going to let this tool know which the tables it should have access to, what the database is, and then there's our service context, once again, showing up to make sure that we're passing it in whenever we're setting up these new tools. And that's it. All we have to do now is wrap this thing in a query engine tool. And all the query engine tool is going to do is going to call this NL to SQL query engine, and then it's going to parse that response, which is going to be kind of jargony and in SQL format, and it's going to convert it to natural language for us. So we don't have to think, we just got to read. Once again, we are not just programmers, we are also prompting, right? So this whole description is critical. We need to ensure that this description makes sense in order for our natural language to SQL tool to be leveraged correctly. So you'll see that we have Barbie, which is going to contain information related to reviews of the Barbie movie. If we didn't put this information in the description, then our LLM could not make determinations about how to interface with this tool. So once again, we are not just programming, we are also doing prompt engineering. The metadata is passed in through the natural language to SQL tool. So it's all done through this. The schema as well is passed in when we create the SQL database in LlamaIndex. And that's going to keep track of all of that metadata about our SQL tables. Once we have the query engine tool set up to work off of our SQL query engine tool, we are good to wrap this in an OpenAI agent once again. And the tool we're going to pass it is the SQL tool. And we can do things like, what is the average rating of the two films? You'll notice that it gives this information, right? Table Oppenheimer has columns, and then it's got all this information. And then table Barbie has all these columns, got all this information. And the idea is that it's going to be able to get a response for us, but we also get to see some of the information it's looking at, right? Which is this schema. And that schema is going to help OpenAI determine which SQL queries to write. It sure can do a join, yes. We have an example from another event where it does a join, and everyone collectively in the audience, you can hear it. Their minds exploded because joins are a pain to write. But we get this response. The average rating for the Barbie film is approximately 7.36, while the average rating for the Oppenheimer film is approximately 8.35. And we didn't have to do anything. We just supplied it with data, asked the question, it did the queries, and then it gave us a natural language response. And with that, all that is left is to combine the two, but we'll learn a little bit more about that from Greg before we see it in code, I believe.
Yep, and we're just going to go ahead and combine these two things just the way we have been chatting. We're going to allow this LLM-powered knowledge worker to go ahead and select and smartly filter, looking at the query, looking at the metadata, deciding which metadata to filter by, and ultimately providing that agentic reasoning and that classification of which tool to pick up. Namely, are we going to pick up the contextual data from Wikipedia, or are we going to pick up the quantitative data from IMDb? Which one do we need to answer the question? Because we put together an index and a query engine for each, and we went ahead and combined these two into a single stack agent reasoning tool with a LlamaIndex data agent. So we're going to see the final piece, which is the big reveal from Chris now, and we're going to see exactly how it responds to more interesting queries that might require one or both of these indexes to respond to. Back to you.
Thank you, Greg. And now, this is where the magic happens. So we combine them. It's a very intricate process to combine them. You'll notice that we've added both to the OpenAI agent. And that's it. That's all you got to do. You know, the OpenAI agent is able to work with a number of different tools. And that is basically what we're going to do. So the idea here, isn't the content going to be the same in this specific case? Of course, it may differ. It's going to be, it can be the same, but it can also be slightly different. So we can have information, say quantitative information about the reviews, like the average review, what the lowest review was, yada, yada. And then on top of that, we can have, information like who was in the film, which is going to be sourced from the Wikipedia article. Is there a Llama 2 agent as well? There is not in this format a Llama 2 agent, though there is generally a data agent that you can use. Yes, that's going to be suitable with Llama 2, but this OpenAI agent works in a very specific way to OpenAI, so there's not a immediately portable solution for Llama 2, though LlamaIndex does have Llama 2 compatible agents. So we can ask things like, what is the lowest rating of the two films? And can you summarize what the reviewer said? And in this case, we get the sequel query, which is going to give us the lowest rating for both films. And then it's going to discuss what that particular reviewer said. We can count things like how many times did the reviews mention Ken, and what is the summary of his character in the Barbie movie. And then we can see in the Barbie reviews, Ken was mentioned a total of 30 times. And then as for Ken's character in the Barbie movie, he is a male dog who plays a specific, and on it goes. The idea is that the information for the reviews is sourced from the sequel tool, and then the information about his character is sourced from the Wikipedia tool. So it shows our tool is not able to just use one or the other tool, but can also, when suitable or necessary, leverage both tools in sequence freely. So the agent itself that's created is it has the capacity to make a decision about whether or not this is sufficient information to answer the question. And if it's not, that it needs to use another tool or leverage another tool to provide that information. So the idea here is that these agents do work in an intuitive way. If we give them a bunch of different tools and ask them a very complex question, it's likely they're going to pick and choose from a number of tools in sequence in order to provide you with a full, well-rounded answer. Obviously, if you're using models outside of the closed sourced, kind of very big, very performant language models, you might find that the performance does not scale as well to many tools. Things like smaller models are going to be using, capable of much less complex reasoning tasks, which is just known from the literature and the benchmarks. So hopefully not too unexpected. How is it under the hood the agent is selecting the route? Yeah, so basically it just sees, it looks at the query and it says, what tool is most likely to be able to answer this question? Then it uses that tool. It gets a response, which we send back to the LLM. And there's essentially just a check. Does this fully answer the question? And then the LLM will either say yes and return the final response, or will say no and will return a tool response. And so that's the basic flow of the OpenAI agent for LlamaIndex. And that's it. There you go.
Woo! That was dope, Chris. That was, as we saw in the chat, the next level of building these things out. And, we've seen so far, we can do pretty awesome things in LlamaIndex. Nodes, indexes, query engines, and now data agents. And we did learn in LangChain already, models, prompts, chains, and indexes. We haven't talked about agents, although, again, we will provide some additional React agent up-to-date content for everybody in following this today. But the principle is the same across any of these sort of agentic reasoning engines. And the principle is this, right? How would a person do this? How would a person get this question and be like, what should I do next? Which tool should I pick up? Well, this tool right here is good at this thing, so probably I'll pick that one up. And maybe I'll take the data from that and I'll consider this other thing that I found and I'll try to merge these together, right? So what we find is that if you can't think through how a person would do it, you can't write the code to tell the AI how to do it, because the code needs to be written in natural language. This right here is prompt engineering. You're telling the model what the tool it can use is useful for, is good at, when it should be called, how it should think about this particular tool. And then you let it do its thing. So the AI engineer is also a prompt engineer. The AI engineer of the future must be good at prompt engineering. Sorry, developers, you don't get out of having to write proper English just because you write code anymore. So in conclusion, we see that LlamaIndex is a powerhouse with combining data sources. And I mean, it's all about that data, right? It's all about that data. So it's not real surprising that they tripled down on this, and it's LlamaIndex. They're very index focused, hierarchical, parsing, chunking, every type of data. Check out LlamaIndex. They're building, ship, and share on like absolute legends these days. It's a great follow-up tool to LangChain to add to your toolkit, which is why we hope to see some of you build with it today. And that's it for this session. Next up, we're going to talk about how to leverage open source models directly from Hugging Face without leveraging a tool like Gradient, so that you can, if you want, build, ship, and share with any model that you can find on Hugging Face. Thank you so much for your attention, and we'll see you back for the next session.